Hello, everybody. This is Eyal. This is the AI in the Enterprise virtual user group. And we are very excited to have Dan Lane from IBM Watson with us. And this is an interesting subject that we have is about explaining and teaching AI and machine learning to kids. And sometimes the best way to get to understand any subject actually is by trying to teach it. And I'm anticipating all kind of cool tools that you're going to see. And I'm going to leave the stage to you. It's nice having you here. Thank you for staying up late and joining us.
No problem. Thanks for having me. Thanks for the invite. So, yes, my name's Dale. I'm a developer for IBM. I don't really have a background in education. I sort of fell into doing this as a side thing accidentally, really. It started as wanting to explain to my kids, who were quite young at the time, sort of primary school age, when I started working in Watson. I would come home from work and try to explain to them what I did at work every day, and they didn't get it. It just didn't resonate. It didn't click. And then one holiday, it was a rainy few afternoons, and I thought instead of trying to tell them what I do, I would get them to play with some of the tech that I worked on and get them to try and make something with me. And we made a game. We made, I think it's something that's worldwide. Guess Who? I hope that you're familiar. Guess Who is kind of like you get this board of faces and you have to guess what face someone else has picked by asking questions. And you would ask questions like, are they wearing a hat? Do they have glasses? And you would use that to eliminate all the options until you found the right face. And I, with my two daughters who were, like I say, sort of primary school, so that's in the UK, that's sort of like under 11. We made a really simple game, and it was basically bolting together a text classifier to recognize the intent of the question. So we trained it with a bunch of examples of, are you wearing a hat? Do they have glasses? Are they male or female? And an image classifier that trained with a bunch of photos of faces with hats and without hats, with glasses and without glasses. And by making something for themselves, it was just two really simple classifiers with a tiny toy amount of training data. But by going through the process, suddenly it clicked. Suddenly all the stuff I'd been going on at them about suddenly made sense. And that was kind of like, I know a lot of your engineers, right? Learn by doing, learn by making. It's how we often learn things. And so it maybe is no surprise that that's what works for them. But that kind of was the start of my journey in this, because I loved sharing. So I made a few other projects with my kids, and I loved sharing what I do at work and what I'm passionate about with my kids. And I would mention this to people I know. And before you know it, I'm at my local school showing a class and getting them to make some little AI projects. And the school down the road heard, and they said, "Oh, can you come in and do something with us?" So I was doing another school down the road, and like, word spread, and just by word of mouth, sort of accidentally, I ended up building up this set of resources that are used by loads of schools now. So that's what I'm going to share with you tonight. I will share with you some tools that I've made, but also some tools that I found that I really like using with classes. Um, and like I say, I just wanted to share the kinds of tools that I found, and I'll talk a bit about the experiences I've had, how I've seen school children react, what they've sort of got on well with, what they've struggled with, and that's kind of what we'll be going through tonight. So let me share my screen, because I've got some sort of like a video. I wasn't brave enough to do live demos. So that was a brief pause after my intro. So yeah, what I'm going to be doing is going through a bunch of tools that I've used before and share some of my experiences using them. So let me get that out of the way so I can actually see my own slides. That'll be helpful. So I'm going to start with one that was made by Mozilla. You probably saw in the news a little while ago, there was some talk about the use of machine learning for recruitment. there was a particular company that got in the news because they'd been using machine learning to screen CVs. And what they found was by training it with the hiring decisions that they'd made, they'd put a lot of bias into this system. So this is a little game from Mozilla where they get students to, and you see in the top right, like a little pretend CV. And the students have to decide whether or not to accept or reject the applicant. And the game ratchets up the tension. It makes them make more decisions more quickly. It gives them time limits. It gives them deadlines. It makes them go faster and faster and faster. And then it starts offering them the chance to automate some of the decisions to help them with a model that's been trained by the decisions that they've been making. And it's essentially what it does is it really pushes the students to train quite a biased model without them realizing. And then it shows them the implications of some of the training that they've done. And it is a great way of sparking a conversation about how bias is unwittingly introduced into machine learning systems and the responsibilities that those of us in this field have, and how appropriate it is to use this kind of tech in these kinds of ways. And by just getting the kids to play this fun game, it gives you this opportunity to have that discussion with them, because it sort of gives them enough insight gives them enough literacy into the issue to have that discussion. It's a really, really cool game. I'd highly recommend it. The URL's at the bottom, as with all the things I'll show you, survivalofthebestfit.com. One from MIT. Now, I've got to be honest, I've never used this with a class, and I'll explain why in a moment. But I've got friends of mine who are teachers who have, so I will share what I've heard about that. This is, I'm sure, you know, if this is a group that's familiar with AI, you'll have heard of the trolley problem, so I won't explain that. But this is basically like an animated, friendly version of, interactive version of the trolley problem from MIT. And the idea is it presents you with these choices, and it forces you to make a decision between two sort of negatives. You know, what should the car do? It's in a situation where it's gonna have an accident. What should it do? And then, as you can see here at the end, it shows you the implications of the training you've done. And again, similar to survival of the best fit, it's kind of, there are patterns in the training data that often the students won't realize that they had. Now, like I say, I've been really nervous about, you know, particularly when I go into schools, it's working with classes that I don't know very well. So I'm really wary of bringing up like car crashes as potentially quite a dark subject. But friends of mine who know their classes very well and are confident they can sort of introduce this without it being a problem have done it, and said that, again, it sparks a really interesting conversation about ethics, ethics in AI with the students. This one, Quick Draw from Google. This one is kind of a fun one. This is one that I save. Like if I've got to the end of a class and I've got 10 minutes left, this is what I use to fill the end of the time before the lesson. It's because there's not very much to it. You do a drawing, as you can see here, and a neural network will recognize what you've drawn. It doesn't really explain much about what's happening under the covers, which is why I wouldn't do a whole lesson on it. But the kids do tend to enjoy it. So it's kind of like, and particularly the few classes that I've had more than once, they're often asking, like, as a treat, like, oh, can we do quick draw at the end? So I think the positive is it sort of is a nice way of showing the kids what's possible. And when you get to the end, actually, it does show you some examples of the training examples for that class that is found. So it sort of shows you a comparison of your drawing in comparison to some of the training that it's had from others. In fact, let me skip in the video to where you can see there, like, you can choose one of the drawings that you did, and it compares it to some of the ones that it's had in its training. So yeah, a fun little quick game, not quite as deep as some of the other ones, but a fun one. At the other extreme, also from Google, this one is really well known. So you might have played with this one yourself. Teachable machine. So it's TensorFlow in JavaScript form. It's a way of training simple neural nets in the browser. And the nice thing is there's like virtually no server infrastructure involved. It's entirely browser based, which is actually really convenient for in the classroom, nothing to install. So what you're seeing here is I'm quite a Doctor Who fan, so I trained a model to recognize some of the little Lego Doctor Who figures I have on my desk. So holding up a character to the webcam, holding down the button, as you see on the right there, collecting loads and loads of training images for that. And I just repeated that for a few different Lego figures. So, you know, Tom Baker, I think I did next. Hold that one up to the webcam, and again, hold down the record button. And then, because all the training examples with this are sort of local on your machine in local storage in the browser, so you can afford to just sort of collect loads just by slightly moving around your object in the webcam. And if I sort of spin it on a bit, so I've got David Tennant and William Hartnell, and once you've clicked on train, it chugs away in the background, takes a couple of minutes to train, and then you can see it in the browser. You get a little test window on the right. So there we go. So this little window on the right, you can hold up an object, and at the bottom you can see real-time sort of output from your machine learning model. So it's a nice way for kids to train a model on anything they can think of. They can pick up any objects they happen to have in the room. They can use their face and their friend's face. They can use like any object they want, and they can sort of see what objects come off as similar to each other, what objects are very different. It's a nice way for them to make a model for themselves. It's a bit limited though that you're using the model in the browser just in that very constrained test window way. So one of the things I've done with this is one sort of quick intro. So those of you who have children, you might be familiar with this thing called Scratch. Scratch is a visual drag and drop block-based coding tool from MIT, widely used in schools, particularly in the UK. It's used in pretty much all schools. It's part of like our national curriculum. You'll find that all primary age schools will use that as their introduction to coding. So it was a tool that I knew students and schools and teachers would be very familiar with. So what I did with, and again, the URL here is machinelearningforkids.co.uk/pre-trained. I'll show you how that all works in a moment. I took advantage of the fact that Teachable Machine has a really nice feature where it will host the model that you've trained for free, which is really cool of them. So you click upload, as you can see I'm doing here, and then you get this URL where they will host the model you've just trained. So what I did was sort of combined that hosted model with this online web-based drag and drop coding tool that students are really used to using and really familiar with, and basically added that machine learning model that you've trained in Teachable Machine as that new set of blocks on the left-hand side. So here, what I've made is just a really simple recreation of that test window, but in Scratch, in something that the students can code. So what you're seeing here, if you're not familiar with, on the left, that's the code in Scratch. It's just in a forever loop, so it's in like a while loop, and it's constantly trying to recognize what it can see in the webcam, and it's displaying the variable up in the top corner. But the point is, by putting this in a programming environment, the kids are now free to make a game, a project, you know, get it to play sounds when it recognizes a different dog, so get it to do an animation, get it to change the background to something appropriate. You know, they can, whatever they can dream up, it gives them that chance to be creative. And I like this idea of putting a machine learning model into Scratch, into this friendly sandbox environment that students are already familiar with. So as well as, you know, models from Teachable Machine, I've added in a whole load of different machine learning models that students can start playing with. I won't go through all of them, but I'll show you a few examples. So ImageNet is one I'm sure you've used before. It's sort of been trained to recognize about 1,000 different types of thing in a photo. So by putting that, you know, representing that as a block in Scratch that students can make something with, they can, even with only a few blocks, they can make something like this that can recognize what's in any photos that they give to it. So it's kind of giving them, giving students the tools that we're used to using in the framework and the platform they're familiar with, and just letting them be free to be creative and make things. And I'll show you some of the more interesting things they've made in a moment after I've sort of gone through this idea, like the basics. What are the pre-trained models? Face recognition, that's a fun one. So doing like face filters, things like putting an emoji mask on their face, or you know, putting little animations on their face. Really simple to do with just a few blocks, but it's something particularly I do a lot of work with sort of age 7, 8, 9 sort of kids. So something like this is really fun, and it gives you a chance to sort of start to introduce them to what's possible with the tech. For some of the more complicated models, I really like the question answering one. And this is maybe showing, that because I worked on a few question answering sort of QA systems in my time. And I love the fact that now it's simple enough that we can put it in a browser and let students play with it. What this project is doing is it's doing question answering on a really constrained corpus, a single document from Wikipedia, and then it's letting them ask questions where it will look for the answer in that one document. But it's going to, actually try to parse the document, pick out the specific answer, so they can build like simple quiz games like this just for themselves in Scratch, which is really fun and amazing when you consider like how 10, 15 years ago, how crazy challenging this was to do. So pre-trained models are fun, but what I really like doing and what I find the children learn the most from is letting them train the model for themselves. So I spent a while building up this tool that I'll show you now, machine learning for kids again. But what this tool is about giving students a really simple, child-friendly interface for training classifiers. And then again, integrating with Scratch. So once they've trained their own custom machine learning model to do whatever they want, they represent that as blocks in Scratch and they get a chance to make something with it. So I want to show you some of the things that students I've worked with have made, and I'll tell you a bit about, the experience they had with it. So, it's sort of project based. So the idea is they create a project and there's lots of different types of model that I support now. So I'll start with showing you like a categorical data. So sort of actually, so for this one, sorry, text. So that you can train it to recognize text, numbers, pictures, sound recordings, all that sort of thing. It's all supervised learning. It's all classifiers. So essentially, they create these buckets. They create classes represented as these big boxes, and then they create training data to put in the boxes by just clicking on the plus. So they come up with all the training data themselves. So it's all really sort of small toy training data sets, but enough for them to start to get a feel for how this stuff works. And then once they've trained the model, most of the work I do is in Scratch, but I have over time added in integration for other educational environments like App Inventor, which is for making Android apps, and Python, which is preferred by some of the older kids. So the kinds of projects that students do. So this one, this is one of the simplest projects I do with some of the really young kids. It's about training them to training a model to recognize if a glass is half empty or half full based on a percentage of how much liquid is in the glass. So it's not a challenging thing, but the idea is it's a really simple thing for them to make. So they collect the training data in Scratch. So what you're seeing here is like an animation that we make in Scratch. It sets the water level to a random amount, and they choose if they think it's half empty or half full. They click on the button, and then the percentage is added into one of their training buckets. So they train it based on their experience. And the nice thing about a model that's this simple is it's really easy to visualize. So what gets built under the covers is a decision tree classifier that they can then go in and see. So they can start to get a bit of a feel for what they've built under the covers. So that's kind of like a simpler one, but let's get a bit more complicated. This one is based on Pac-Man. So again, they collect the training examples by playing a game that they make for themselves in Scratch. So they make a little Pac-Man game, and every time they press left, the coordinates of the Pac-Man and the ghosts are added into the bucket of training examples for left, and for down, and for right and up. So that the more they play the game, the more training examples they collect. And actually, particularly with the young kids, it's hard to get them to stop playing the game. So actually collecting loads of training examples is no challenge at all. In fact, getting them to get on with the lesson is the hard bit. But once they've collected the training examples, they put their machine learning model in control of Pac-Man. And as you can see, it's a really simplified version of the game, so we can do it in a single lesson. Only one ghost and not many obstacles, but enough for them to start to see the impact of their training. They start to see, and particularly when you do this in a class with like 30 kids, one student will see their Pac-Man behave differently to how the student sat next to them will behave, because each one is training their own model, and their Pac-Man will behave in a way that reflects the training they gave it. And they also get to see things like the impact of the amount of training data, because they'll train it with a few moves and it'll be really bad and it will run straight into the wall or straight into the ghost. And then they train it with a few more examples and it gets a bit better. They train it with more examples, and like the more and more training examples they give it, it gets better and better until the point where it can just evade the ghost forever. So they start to see for themselves the impact that the correlation between the amount of training data and the performance of a machine learning model. So without me having to tell them those kinds of basic lessons about how the tech behaves, they just stumble onto those lessons through first-hand experiences, which I really love. I'll skip this one in the interest of time. That one's hand gestures, but it's a fun little one. Let's look at a text one. Things like Alexa or Siri are a really nice example. You know, typically all the kids I'll have in the class have either got an Alexa or they're at least aware of it. So it's nice to get them to build examples of things they're familiar with. So this is a really simplified example, you know, training it to recognize two commands, how to turn on a light and how to turn on a fan. And they will collect examples of how they would ask someone to turn on the fan and turn on a lamp. Use that to train a simple text classifier, and then they can make themselves a little Alexa or sort of mini Alexa in Scratch, something that they can give it a command phrased in natural language in a new way that they haven't shown the computer before, and the computer will have learned how to recognize the meaning of that command and take an action. And the nice thing is, you know, by making something like this for themselves, suddenly that Alexa isn't this black box that just magically knows what they mean. They start to get a little bit of insight into what went into making it. And it opens up all sorts of discussions, because again, when it gets something wrong, you sort of ask them, well, what are you going to do now that it's misunderstood this? And with a little bit of nudging, students will often go, oh, well, if I add that into my training examples, then it will get better and it will get that right next time. So you sort of go, okay, well, why don't you give that a try, see how it does. So again, when they see stuff in the news about, you know, companies like Amazon who are collecting examples of or using examples of real life utterances for training the system to improve the way it performs, now the students have sort of got some insight into why companies behave like that. You can have a really interesting debate with them about, well, is that appropriate? You know, how comfortable are they? You know, is it appropriate? At least, I'm not saying you persuade them that it's right, but you at least give them enough of an understanding to understand the motivations and see why companies behave the way they do in terms of collecting data for these kinds of projects. Another text one, this one, instead of recognizing the meaning, the intent of text, this one is about essentially sentiment analysis. So I get them to collect examples of the nicest, kindest compliments they can think of and the meanest, cruelest insults they can think of. And this is a risky thing to do with a bunch of teenagers. This one has, I've seen some interesting language. Depends whether or not the teacher is watching them closely of how this goes. But again, getting them to sort of see how the tech behaves in a different sort of use is really interesting. And what they'll do is they'll make something like this, a character that reacts based on what you say to it. So you say something nice to it and it smiles. Typically what the boys will end up doing is say something mean and horrible to it so they can make it cry. I've seen students do more creative things. I had a student once who made a dog, and if you said something nice, they animated the tail so it would wag, and if you said something mean, it would look sad. It was really, really cute. So it's a nice introduction to what sentiment analysis is and how we use it. With older students, it's a chance to talk about, you know, why, you know, what the edge cases, what the limitations of this technology are. You know, why do companies like social media companies struggle to deal with toxic language? You know, how good is the tech at recognizing sarcasm, things like that. But again, instead of just telling them about these things, giving them a chance to play for themselves and to stumble onto some of these lessons and to see for themselves where the limitations are through experimentation, you know, give them a sandbox and let them play, I find is a really great jumping off point to have those conversations. Chatbots are a really, I've done loads of variations of this project, basically getting them to research a subject. So this one was about the moon. I can't remember why. Come up with what they think the most commonly asked questions are, create a bucket for each of those questions, you know, how far away the moon is, how big it is, and so on. And then fill those buckets with examples of how you would ask that question. And then they make a little character to give the answers. So, really simple chatbot, recognizes the intent of a question and then returns a pre-scripted answer. The nice thing about this is I can work with a teacher to adapt this to whatever the class are currently doing. So if the class are doing, learning about Vikings, then we make a chatbot Viking that you can ask it questions about, what clothes did they wear and what sort of foods did they eat and whereabouts did they live and that sort of thing. If they're doing, if they're learning about William Shakespeare, we'll make a chatbot William Shakespeare that can answer questions about where Shakespeare lived and what plays he wrote and that sort of thing. So I've helped classes to make chatbot politicians and historical figures and animals and all sorts of things. And it's nice to have a project like this where it's not only about the AI, because a big part of this subject is them researching the topic and working out what questions people might ask and coming up with ways of asking that question and scripting the answers. Some of the students really get into animating their avatar. So it's a nice thing that all the students can engage with, not just the ones who typically really like coding. So in the same way that teachers might ask students to present what they've learned by writing an essay or doing a presentation, getting the teachers to make a chatbot as just another way of presenting the information you've learned and sort of sliding in an AI element to a history class or a geography class or an English class, I really love, because it is a really nice way of engaging with the whole class, not just the ones who are really into tech. Speaking of embedding it in lessons, this is a project I did with some older kids. There was a secondary school near me where the teacher was doing like a media literacy set of lessons. They'd been learning about how different news media outlets cover the same stories. And what we thought is we would try and do a lesson on, could a machine learning system start to recognize some of the patterns that they've been learning about? So we collected examples of the main newspaper headline from 4 different newspapers in the UK, trained it to recognize those, and then we tested it with examples of new headlines. So we'd give it a new headline the system hadn't seen before, and then it would make a prediction of which newspaper that headline probably came from. And it was a really interesting one to see because, it got quite a lot of them right, which they were really surprised by. But even where it got it wrong, it was an interesting one for where it got it wrong. Like it would confuse the tabloids with each other and the broadsheets with each other, and it also gave us a chance to have that discussion about, well, what sort of patterns do we think the machine learning model is going to be picking up on? Some of the headlines, some newspapers use very short sentences, all in capital letters. Some have much longer sentences. Some have very emotive language. Some use very matter-of-fact language. Some have particular topics they regularly use. So we could talk about what kinds of patterns we thought the machine learning models would be picking up on. And it was a nice way of reinforcing what they'd been doing in class. So again, making the lesson, getting AI and machine learning to complement what they were doing instead of as a separate standalone thing, which is a really nice lesson to teach them that, AI and machine learning is just another tool for them. It's not only for the computing students. I really like doing ethics lessons. I find the students I've had some of the best, most engaging discussions with the students on when we touch into ethics. So with this one, what we did was we built a recommendations engine. Really simple one. It was basically recommending places where you might want to go to visit on a vacation. So you would tell it your hobbies and interests, and then train it to make a recommendation of you should go here. If you like doing exciting, fun things, it might recommend the fun fair. If you want to do something quiet and peaceful and tranquil, it might recommend fishing, that sort of thing. But what we did with this is we got the students to intentionally bias it. So you put in 2 really similar locations, like a theme park and a fun fair, and then you experiment. You sort of see what can you do to make the machine learning model always recommend the theme park instead of the fun fair, or vice versa, in really simple ways, just like by the amount of training data. You only put 2 or 3 examples in the fun fair and 30 training examples in the theme park. And what you find is the machine learning model is heavily weighted and will far more often than not recommend the theme park over the fun fair. And that, it might seem obvious to us who've been working with this tech for a while, but to students who are new to it, that blows their mind. They're so used to this idea that good code modern algorithms, clever algorithms, will give the right answers, and bad code, bad algorithms will give the wrong answers. And that idea that actually, there's an element of that, but the far bigger influence is who's done the training and what training data they've used has a much bigger impact on the answers the system will give. That is new to them, and it's a real and when they see that happen by doing it for themselves, that's a real penny dropping moment. And you can start having discussions with them about, well, hang on a minute, like imagine you had made this tourist info app and you had biased it. Is that fair? And well, it's recommending places to go on vacation, so the students will sort of shrug at you. So then you up the stakes a bit and you say, well, what if the owner of the theme park had paid you a big stack of money to make you put more training examples in the theme park class and to make it favor the theme park? What about now? Do you think that's fair? And because money's involved, some of them will start to waver and they'll start to go, well, actually, that's not fair at all. But some of them will still be going, well, it's vacation, so who cares? So you up the stakes a bit more and you ask the class, well, what if this was not recommending places to go on vacation? What if this was recommending medicines? And this is an app being used by your doctor. You instead of putting in your hobbies and interests, you put in your symptoms, and it recommends a medicine that you should have. And what if the manufacturer of one of the drugs paid a big sack of cash to the developer of the app so it would favor their medicine instead of their competitors? Now, what do you think? And at this point, the whole class is off the fence and they're all going, hang on a minute, is that possible? And it gives you a chance to have that debate with them about the need for transparency in the use of AI and machine learning systems in critical industries like healthcare. And you can have that discussion with like 8 and 9 and 10-year-olds because they have this sense of what's fair and justice and right and wrong. If you just give them a little bit of first-hand experience to give them some context, to show them what's possible, to show them how the implications of how this tech behaves. Sound recording ones are fun. This one is an alien. So this is essentially training a system to recognize a wake word. So you train it by recording noises. So you get the kids to make up a word, an alien noise for left and an alien noise for right. And then when they make that noise, blibble, blork, or whatever, the alien does whatever. And I've done lots of variations on this, like secret spy word, code words for different places. So that the animated spy will go to the right place. But again, it's just about getting them to see how this stuff behaves through first-hand experience. Pardon me. This was one that I saw being made. I love this one. So this is a combination of the face detection model that I showed you before, so recognizing where someone's face and eyes are, and the voice recognition that I've just showed you. So training it to recognize the commands, the voice command, laser eyes. So when she says laser eyes, it fires lasers out of her eye. And she has to use them to destroy the bottle. I do like getting kids to play games. It's a really nice way to get them to engage. And things like this that actually get them to combine multiple machine learning models to do a single a nice sort of intro to get them thinking into how we assemble these kinds of projects. Images are fun, particularly with younger kids where maybe typing is takes them a long time. So pictures are much quicker, so they can drag and drop pictures from another browser window into the training bucket. So they can collect a set of training examples like this really quickly and easily. Opening another window, drag a load of pictures on, and then they can make, in this one we made like an AI machine learning sheepdog that would sort the animals out into the right area of the farm. So it's a use case that a 7 or an 8-year-old can easily understand, and a chance to let them play. And you can it's nice to let them sort of see where the tech breaks, where the edge cases are. So you get them to do something like this, train it with photos of animals, test it with photos of animals. Hey, it works. And then you give them some cartoon animals and you get them to test it, and it starts getting them wrong and puts them in the wrong place. And you go, well, why do you think it's getting them wrong? This is a really smart AI. What's happening? And with a little bit of nudging, even an 8-year-old will turn around to you and say, well, I've only taught it to recognize photos. I've never trained it what these cartoons look like, so it doesn't know what to do with them. Oh, okay, so what can we do about that? Oh, well, maybe we should add some cartoons to the training example. Then we can teach it what cartoons look like. Okay, let's give that a try. We go back, we drag in some cartoons into the training buckets, we give it another try, and it gets them right this time. I love that way of just, letting them hypothesize what's going to happen, letting them come up with theories for why it works, where it's not working, let them try and fix it for themselves, giving them a bit of space in the lesson to experiment and to see what happens. I find it's such an effective way of getting them to understand how this stuff all works. But then I do always resort to getting them to make a game again, because like I say, games are fun. This one is just like a really simple variation on Snap. You hold a card up to the webcam and you have to see how quickly you can get the card that it's asking you for. This is another fun game. And this one, I'm surprised by how much the students really like this. So what they do is they train it with examples of looking at the webcam and not looking at the webcam, either looking away or covering their face or something. And then what they make is a character, a shy character, that will dance when you're not looking. And if you, when you look, it stops dancing because it's shy. So that's the idea. So, you know, starting it here, it sees her looking, it stops dancing. If she covers her eyes, it starts dancing again. Just really fun little game, but it seems to go down really well. I really like projects that show students where AI and machine learning is used in a way that they might never have noticed, because making things like Alexa are fun because it's, you know, in their house and they're experiencing it. But if you can show them something that they didn't even realize AI was being used, that's fantastic, because it starts to open their eyes up about how this tech is already like all around them today. So this one was about looking at the use of optical character recognition, handwriting recognition in sorting of mail. So I got them to pick 3 local towns and to write the start of a postcode, a zip code, for those of you in the US. So I guess the closest equivalent would be like writing the 2-letter code for the state. And they can collect these training examples by writing directly onto an on-screen canvas. And once they've collected, how many have we got here? 15 training examples in each bucket. That's enough for it to recognize these 3 codes. So then we made like a postman sort of game based on there's a cartoon character in the UK called Postman Pat that's really popular with primary school kids. So we made, these are the kind of van that Postman Pat drives. So what we made is a game where you draw onto the envelope and the AI will send the letter to the right Postman Pat van to go to the right town based on what it's recognized. I mean, partly this is just a nice, cool little tech demo, right? You know, this is, the kids like the idea that I write on this and it magically knows what I've written and sends it to the right place. But also you can have that conversation that, you know, large scale sorting offices have automated the sorting of mail and packages through a more, you know, extensive variation of this idea of training it to recognize lots and lots of different types of writing so that it can sort mail for us automatically. So as I say, it kind of allows you to start to open up the kids' eyes to how this stuff is used in loads of ways that they aren't really aware of. This one was basically just because I like the phrase "judge a book by its cover." So this was all based on this idea of can a machine learning model learn to judge a book by its cover? So we trained it again by dragging in from, I think we did this one from Amazon, dragged in loads of examples of covers for different types of books. And then we made, and actually this one we did in App Inventor, that Android app builder that I mentioned earlier, rather than Scratch. Because what we made was an app that they could point a book at, and then it would tell them what shelf to put it in. And because the computing room at this school was based just by the library, so we made a game where they would point the app. Actually, sorry, this is the Scratch version first. Show it a new book, it recognizes it, tells you what type of book it is. But where we had fun with this one is we made this app in Android that you would show it a book, and then they would run to the shelf to put the book on the shelf, based on what this like AI librarian on their phone had told them. And I really like this idea of an AI computing lesson where they're not just sat down the whole time, they're up and they're moving about. It made for quite a lively, sort of fun, boisterous lesson. Although Scratch is a really simple programming environment, you can do some really complicated things. And the last demo I want to show you is this one. And this is one I did with some older kids fairly recently. And this was about trying to get some insight into not just what the machine learning model is telling us, but what it is, why it came up with that answer. So this is, again, that teachable machine model that I showed you at the start, that we trained with pictures of the little Lego Doctor Who figures. And this has recognized that this is a figure of the Doctor, and it's got 99% confidence. Well, that's fine. But what we experimented with is, well, what if we cover different sections of the picture? What it still recognizes this as the Doctor, but the confidence changes. So you see in the top left, when we put the cursor there, where's my mouse point? There's my mouse point. It doesn't change it much at all there. It changes it quite a bit there, changes it a little bit there. So it's kind of like, well, what can we infer from that about how significant an area of the picture that was? So we made a little scratch game that would automatically move that block to every possible location on the screen, make a note of the percentage, and then use the difference score to make like a little visualization. So what they made was this, that the more transparent it was, the more significant it was. So it essentially gave us this heat map of what areas of the picture the machine learning model were finding most significant. And I love that students can make, just in Scratch, in this really simple visual programming environment that is taught to 7-year-olds, they can start to make some really interesting and complex things that allow them to experiment with machine learning models and to get some idea and insight into how they behave. So yeah, at one level, you can make a little sentiment analysis thing that the character smiles if you say something nice and cries if you say something mean. But at the other extreme, I've got kids making things like this, where they're sort of saying, oh, well, it looks like that pattern in the shoe is really significant. And even if we move the Doctor figure around, it really fixates on that, which is so cool. There are loads more projects I could have shown, but in the interest of time, I will leave it there. The general idea is, and what I've tried to sort of get across is, I like this idea of learning through experience, learning through making, learning through doing something hands-on. Get students to train their own machine learning model and give them the time and space to use that machine learning model and make something. And I love it when it's something that shows them a bit about how machine learning is used in the real world, or something that sparks a conversation about the impact that AI machine learning has on their lives, or sometimes just something that's a bit fun. But whichever way we take it, it's about starting to introduce to the next generation a little bit about this tech that we're all using, and to start to get them to engage in some of those discussions about how it should be used and what we're doing with it. And with that, thank you very much for listening. I will stop the share. There we go.
That was quite amazing. I did not expect anything even close to this, so I'm very impressed. I'm not sure why my head shows up so big here, but let me adjust a little bit. So if anybody has questions at this point, you can either raise your hand, or you can just put it in the question and answers tab on the right side of the screen, or just in the chat. Meanwhile, I can ask you if you can share any links or resources or anything that people will be able to use to get started.
Yeah.
And I see that Daryl raised his hand, so let's see if I can invite Daryl to the stage. Maybe he can just talk to us. Oh, it says here I can hand the mic, so let's do that.
All right, does that come through now? Looks
Yeah.
like green. I see the green marks. Hey, first off, that was great. I really appreciate all the tools you have there, and looks pretty accessible. One thing I noticed, though, actually I noticed it before I even started. The big Lego guy with the brainstorm thing on your desk. Have you incorporated any of these tools with that?
No, I have with the Arduino, but I haven't got Lego working with it yet.
Oh, how do you interface with the Arduino?
There are Scratch plugins that will do that as well, which is quite. I mean, when I'm doing it with kids, I'll use Scratch. When I do it, I will use Python. But yeah, this is something called a Teachable. It's like a little 3D plastic, 3D printed
Can
plastic
you show
robot.
the camera, because right now we can only see.
Yeah, the camera it narrowed the view, so I can't see it.
It's
Oh,
quite
that
broken at the moment. Actually, no, this
Okay.
one is this one the Raspberry Pi one. I've got a few of these. Yeah, this one's a Raspberry Pi, but I've got another one in the kitchen that's an Arduino based one. And what this one was doing was like his arm would go up and down, so he can wave at you. And he had cameras for eyes that are currently broken, so he would it did face recognition, and if it recognized you, it would wave at you. And that actually doing something that is real world and physical and tangible is really nice. Like it engages with kids that you don't always manage to reach with just a pure screen-based coding thing.
Right.
So yeah, we basically made like a face detection thing. And yeah, and it's a tiny bit of Python code that would run on here, and then it would wave at you. But yeah, that's called Teachable. All of the recipe and instructions for that are freely online, so it's something it's easy to make.
TJ-Bot, huh?
Yeah.
All right. I'll have to look that one up there.
Anyone else would like to? I see something in the chat. Let's see. Oh, this is what you put on. Let me also show it on the stage, so people in the video can see that too. So this is the first link.
Yeah, and if you click on that link, you can actually see what TJ-Bot looks like when he's got his head on. That I've currently, I'm not sure where it's gone. I broke it.
And I'm trying to show the other one.
And I mean, speaking of URLs, I think the biggest mistake I made, and if I could go back and start again, machinelearning4kids.co.uk. It's a terrible choice of a URL for 7-year-olds. It takes them the first half of the lesson just to type that in, and they'll put a spelling mistake in there and it won't work. So yeah, it's such a bad idea for a URL. I wish I'd picked something shorter.
So what's, when we go to this website, there is a way to contact you, or is there a better way to contact you, or to see more of your?
Yeah, so my contact details are there. I know that teachers find it because so I use a Let's Encrypt cert for the site, and last Thursday I forgot to renew it and it expired. And within about 2 hours, I had something like 100 emails.
Oh, wow.
So it's a nice way of knowing that actually people are using it, because yeah, my inbox exploded. Because unfortunately I had a lot of teachers who browsers give really scary messages when a certificate expires. Like Chrome pops up this thing saying attackers might be trying to steal your personal information. So I had all these really scared emails from teachers going, why are you trying to steal my personal information? I'm not. I'm really bad at automating things like renewing certificates. But yeah, so my contact details are on the site, so please do reach out if you want help with it, or if there's anything you can need.
Okay, so thank you very much. Thank you for staying up late, and I enjoyed it a lot. I'm sure everybody did, and we will have this recording on YouTube soon, and I will send a message when the recording is ready.
Fantastic. Well, thank you again for having me. It was fun.